Good evening, Bearcats. We are in 2.1 quadratic functions, and today we're going to discuss the standard form and the vertex form, and also how to write quadratic functions given a point on the curve as well as the vertex. All right, these are just some examples that you're looking at here at different ways that a quadratic function might be presented to you. So I'd like to think you take a look at that. You may want to just jot them down. Some seem very familiar, some might seem a little less so, but they're all quadratic functions. This one, of course, is a standard form, and this is in vertex form, and this is in factored form. So there's three kind of major ways there. The next thing I want us to look at is the basic standard form of the quadratic. And the quadratic function, not standard form, I'm sorry, the general form of the quadratic, which is ax squared plus bx plus c. And you know this form really well. We use this form when we're writing the quadratic formula. And it's a quadratic function, of course, is a U-shaped graph or U-shaped curve called a parabola. All parabolas have an axis of symmetry and a vertex with either a maximum or a minimum value. So let's talk about that. So if our graph is positive, it would turn upward, and we would actually have a minimum value. And if our graph, if our graph turned downward, we would have a maximum value. All right, let's keep moving on. Standard form. This is the vertex form. We looked at this a little bit in A5 when we completed a square, and we moved it to vertex form. Let's talk a little bit about what you're looking at here. A times x minus h squared plus k, where h and x are your vertex, and of course then h is the axis of symmetry. Let's take this general form we have here and let's change it to standard form, our vertex form, by completing the square. We've done this several times, but let's do this one more time. The first thing I'm going to do is move the 7 over to the other side, and we would end up with 2x squared plus 8x equals negative 7. The next thing we want to do, if there's a coefficient in front of the square term, we're going to factor that out. So take that out. We have x squared plus 4x, and then plus blank equals negative 7 plus blank. Keep the 2, and we're going to complete that square. Remember, we're forcing a number here, so this becomes a perfect square binomial. So we're going to bring the x down, the plus sign. Half of 4 is 2. 2 squared would be 4. Now, on the other side, because we factored out this 2, we're going to have to multiply by 2 here, and this would also be 4 in the blank. So on this side, we have 2 times 4 is 8, and a negative 7, so we have a positive 1. From there, we could solve and get our x-intercepts. We did that a little bit in class on Friday. We could also move the 1 over and make it 2x minus 2 squared minus 1 equals 0. That's in graphing form. And from this form, our vertex, remember, would be our 0, 0 parent point from our parent graph would have shifted to the right 2 and down 1. Well, to the right 2 would be a positive, down 1 is a negative, and that would be our vertex point. I want you to go ahead and solve for x, which would give you your x-intercepts, and then go ahead and sketch a graph in your notes. We're going to have to do this on Monday in class as well. Okay, so make sure you have that ready when I come by and look at your notes Monday. You can go ahead and pause, and I'll be right here waiting for you. The next example I want to talk about is I want us to be able to write an equation of a parabola given partial information. So we've given some information. We've given a vertex and a point on the curve. I'm just going to sketch what that looks like, and I mean really a sketch. Our vertex is at negative 4, 11, so I'm just going to put my vertex there. And I know I have a point on the curve at negative 6, 15. Negative 6, 15. So my graph obviously looks more like this. And there's my vertex point. So my vertex is at negative 4, 11. Remember, our vertex is our h and our k. And we have a point here at negative 6, 15, which is an x and a y. The next thing we want to do is we really have to have that form, that graphing vertex form, standard form of a parabola written down. And so let's go ahead and rewrite that. We know that should be y equals a x minus h squared plus k. and then we can kind of plug in. To write the equation, this is much like when we did our equations of variation where we solved for a particular value. In that case, it was a constant, and then we went and plugged it back into our equation and left the x and y there as variables. We have a similar process here. We have h, k, x, and y, but we don't have our a value, so we need to solve for a first. So let's plug in what we know. We have a y value of 15. We don't have an a value. We have an x value of -6. We have an h value of -4, but it's minus h, so minus a negative puts us at +4. That will be squared, and we have plus k, which happens to be positive 11. So when we clean things up here, we get 15 equals a times. We have -6 and 4 is a -2. -2 squared would be a 4. So actually, I'm going to write that as 4a, and then plus 11. And we're going to go ahead and solve. So we would subtract 11, divide by 4. Subtract 11 gives us 4a, divided by 4 will give us 1. So our a value will be 1. Our a value will be 1. Now, to write the equation, we have our a value, we have our h, and we have our k. We want to leave the x and y as x and y. So to write our equation, we're going to write y equals 1 for the a value, x, and we know it's x minus a -4, so plus 4 squared plus k, which is 11, and this would be our equation. That way we could plug in any x and find an output that we wanted along our curve. All right, make sure you have that written down and make sure you understand that. I think you might see something like that when you get to class on Monday. Next, I want to talk a little bit about applying this information. Notice again we have our general form ax squared plus bx plus c. And another way that we can find a vertex is something you're familiar with, is that whole x equals -b over 2a. So that's our x value. That's why it's here in the ordered pair. If we're looking for the vertex, we have to take -b over 2a and plug it in to solve for y. And remember, our y is the same as our f of x, except we know that the x value is plugged in to solve that. So that's why you see this notation that the vertex is -b over 2a, comma, f of -b over 2a. That's where the notation comes from. You need to really think about the notation, because sometimes as you move up in math, that's what gets you is the notation. You have to understand the math language to understand what they're looking for. This particular problem talks about a baseball, and it's given by the following function. And the baseball, f of x, or the y, gives us the height above the ground of the baseball. And the x in this case is the distance from home plate, the distance away from home plate. So let's take a look at this. If it's a negative, we know our graph would turn downward. Just going to kind of do this. And this is the distance from home plate. And this would be the height. And that would be the height above the ground. All right, let's see what it's asking. It says, what is the maximum height reached by the ball? Well, max would be the vertex. We have ways to find the vertex. The vertex is going to be an ordered pair x and y. And now that we labeled our x and y axis, we know x is the distance from home plate and y is the height. So this is like the distance and this is like the height. What do we ask for? What is the maximum height? So we're going to want the y value of that parabola, the y value of that parabola. Well, with this particular problem, then we could rely back on, since these numbers are not really pretty, completing the square would not be probably a preferable option to get it into vertex form. So we would rely on the old, we have to find the axis of symmetry, or the x value first. So x equals -b over 2a. And in this case, that would be -1 over 2 times negative 0.0032. And when we multiply that out, we would get 156.25. Okay, now that would be the distance from home plate. This is the distance from, from home plate. Well, I can't spell tonight, or I can't write well tonight. Let's see. There we go. This would be the distance from home plate. Now, to find the actual height, we would need to take this value and plug it back in. So we would have to have -0.0032 0.0032, and we would plug in 156.25 and square it, plus 156.25 plus 3. When we go through and use that and calculate that, we're actually going to get a value of 81.25 feet. So the height above the ground when the ball is 156.25 feet away from home plate is 81.25 feet, which is the maximum height that the ball reaches. So you need to go back and think about all that you found and what it means. What I'd like for you to do when you come to class, I'd like for you to go ahead and turn on your dyno and follow the directions on the screen, but I would also like for you to grab a graphing calculator and see if you can put this equation in the calculator, and on the calculator find that ordered pair of max height, or the maximum value, which is the vertex of that graph. I'd like to see that. When you find it, why don't you just kind of notify me and let me come around and see that you found it and make sure that you can have that technology piece and understand how to use your calculator as well. After we do that, then we probably won't use them much the rest of that day. All right, let's take a look at the last problem. This is about a company that produces soft drinks, and they're talking about the cost associated with that. So this is the production cost for a soft drink manufacturer. And when we talk about costs for a business, of course, the business wants to maximize its profits or maximize its revenues, but for costs, we want to minimize them. We want to minimize them. So we'll be looking for a vertex again, but at a minimum value. They gave us the formula. Be really careful. It's not in the proper form, so let's kind of rewrite this as 0.075x squared minus 120x plus 70,000. Okay, so there you are in the right form. Again, this is a positive, so you're going to have a graph that turns upward, giving us a minimum value of x and y. And let's take a look at what they're wanting to know. This is the cost, so C of x, the cost, so if I put this on this grid, the cost is going to be our y value, and our x looks like it's going to be our units produced. So the question here asks how many units, okay, so we want to know units, so we want to know our x value, should we produce to yield a minimum cost. So we want to know how many units, so we want to know the x value at the minimum, which is at the vertex, and find the x value of vertex, just the simple old x equals negative b over 2a. Let's go ahead and plug that in. That would be negative b, so negative 120, which would be a positive 120 over 2 times 0.075, and if we multiply all that out and simplify that, we should get 800, which would be units. So in other words, we have to produce 800 units to minimize our cost, to have the least cost. That'd be the most cost effective for our company. All right, I hope you have a really good evening, and I will see you tomorrow. Night, Bearcats.